Hello and welcome back to my channel. So, in the previous few classes, we have covered various concepts related to switching theory and logic design, especially number systems. So, let me present a brief summary of what we have covered in our previous class. Then we'll move to our actual topic in this class. So, in the previous classes, we have covered what is meant by a decimal number system, and after that, we have seen what is meant by a binary number system. Later, we have understood what is an octal number system. Then, we have seen hexadecimal number system. In addition to that, we have also understood how to convert a binary number into a decimal number and an octal number into a decimal number, a hexadecimal number into a decimal number. In all these in previous classes we have covered all these things. Now in this class I will start reverse conversion. What is meant by that? If I want to convert a decimal number to binary, how can I do it? Similarly, if I want to convert a decimal number into octal number, or if I want to convert a decimal number into hexadecimal number, how can I do it? We'll see from this class onwards. So by now I hope you have understood the importance of this class. So here we will understand in this class how to convert a decimal number into binary number. If you really go through this video completely without skipping any part, you can easily understand the remaining conversions like decimal to octal, decimal to hexadecimal. Okay, so let me quickly go into that topic. Okay, let us move to the topic. So today's topic is decimal to binary conversion. How to convert a decimal number into binary number. Okay. So I request once again, this class is very important. Before without skipping any part, you please go through the complete video. Okay. Now, if I want to convert a decimal to binary, we'll follow two different methods. So first method is for if the decimal number contains only integral part. If the decimal number contains only integral part, we'll apply successive division method. What is the method? This method is called as successive division method. If the given decimal number is contains only integral part. Okay. And if the given decimal number contains fractional part, if the given decimal number contains fractional part, then we will follow successive multiplication method. Successive multiplication method. Okay. So let us see both the things. And if the number contains both the integral part and fractional part, you can apply successive division method for integral part and successive multiplication for fractional part and add them together so that you can easily convert the decimal number into binary number. Okay, so let me do it. What is meant by successive division method? You can easily have an idea if you go through a numerical problem. So that's why I'm taking the help of a numerical problem. So consider the first problem. So I want to convert a decimal number 36. Let me convert the decimal number 36 into binary number. I just want to convert it into binary number. So the base for binary number is 2 and decimal number is 10. Okay, so we need to find this number. How can I do it? First write 36 as it is and divide this 36 with 2 first of all. So when you divide 36 with 2, what is the quotient? 18, right? 2 18s 36. So the quotient is 18. And what is the remainder? 0. So quotient must be written here and the remainder must be written here. Then you need to divide this 18 again with the 2. So 2. So what is the quotient? 9 is quotient and remainder is 0. Later you need to again divide 9 with 2. So 2 4s 8. So quotient is 4 and now the remainder is 1. Is it right or not? Similarly, again divide 4 with 2. So 2 is quotient, 0 is remainder. Finally, divide 2 with 1. Quotient is 1, remainder is 0. So you can do up to this step until the value or the quotient which we have got is less than the base into which we need to convert the number. Okay, so after we got this, we need to move in reverse direction. Means this is the last quotient and this is the first remainder. from last quotient to first remainder you need to write the digits. Okay, so considering this as a MSB and this as a LSB, which is the least significant bit, I can get the bits as 1 0 0 1 0 0. So this is the equivalent binary number for the decimal number 36. Okay, so you can easily verify your answer by just converting this binary number into decimal number. Okay, if you don't know how to convert this binary number into decimal number, so previously I have done a video on that. Please go through that video in order to check your answer whether it is correct or not. Okay, so this is the first problem. Next, second problem. So I want to convert the decimal number uh, 32, or let me, okay, 32. So I want to convert the decimal number 32 into binary number. How can I do it? Just if it has only integral part, you can use the successive division method. This entire process is called as a successive division method. This entire process is called as successive division method. Next, going to successive division here again. So 32 is the given number. Divide this 32 with 2. So 2 16s 32. Remainder is 0. Quotient is 16. Divide this quotient again with 2. Quotient is 8. Remainder is 0, and again divide this 8 with 2. So 2 fours 8, remainder is 0. 2 twos 4, remainder is 0. 2 ones 2, remainder is 0. Now as the quotient which we got is less than the base into which we need to convert, I can stop here. And in which direction I need to move? I need to move in reverse direction, means from last quotient to first remainder. Okay, I need to move in this direction. So this digit is considered as MSB and this digit is considered as LSB, least significant bit. Now write the digits. 1 followed by how many zeros? 1 2 3 4 5. So 1 followed by 5 zeros. So this is the equivalent binary number for the given decimal number. Again, you can check your answer by converting this binary number into decimal number. Okay, so this is the first method, which is especially useful when the given decimal number has only integral part. Okay, now let me go to the second part. Second part is fractional part. Fractional part. Okay, so in order to understand how to convert a fractional part into its equivalent binary number, let me consider one example, which is 0.375. Okay, so if I want to convert 0.375, this is the decimal number, I just want to convert it into equivalent binary number. So I just want to convert it into equivalent binary number. How can I do it? I can do it by using successive multiplication method. Okay, successive multiplication method. So let me change the color for fractional part. Let me change the color. So first problem, 0.375. Okay, so I want to convert this decimal number. So this is the decimal number. I just want to convert this decimal number into binary number. Okay, how can I do it? So just multiply 0.375 with 2, because this is the base into which I need to convert the given decimal number. So I am multiplying that with 2. So 0.375 into 2 is 0.75. Okay, in this 0.75, 0 is the integral part, 0.75 is the fractional part. Write integral part separately. So 0. Next, take 0.75 again. When you take 0, you have again 0.75 here, and multiply this 0.75 with 2, you will get 1.5. So in this 1.5, 1 is the integral part and 5 is the fractional part. So write integral part and write the remaining fractional part here. Multiply this with 2. So what I am trying to do is I am successively multiplying with 2 by separating the integral part in each and every step. Now 0.5 into 2 is 1.0. 1 can be written also as 1.0. So if I take the integral part separately, I'll have 0.0. So 0.0 multiplied with anything is 0. So I want to stop here. So when I can stop, I can stop this successive multiplication process when the multiplication of the previous previous fractional part and the base leads to 0. the, uh, at this situation we can stop our successive multiplication, or else we can stop at the situation when we got as many digits as possible after the radix point. In these two situations we can stop our successive multiplication method. Now in order to write the binary binary for the given fractional part, as we have moved here in this direction, but here I need to move in forward direction. Okay, so now the equivalent binary number for the decimal number 0.375 is given by 0.0 point. Okay, this is the radix point, and what are the digits after the radix point? 0 double 1. Okay, so this is the equivalent binary number. You can verify your answer again by converting this binary number 0.011 into decimal number. Okay, so if you have any doubt, please go through the previous videos of conversion of binary number into decimal number. Okay, next going to the second problem. Let me go to the second problem on fractional part. Okay, uh, let me do it. 0.225. So this is the decimal part, so this is the fractional part. I want to convert this fractional part into its equivalent binary. Okay, so how can I do it? First take the given fractional number 0.225 into 2, multiply with the radix into which we need to convert the number. So 0.225 is 0.45. Now in this the integral part is 0, so separate this integral part and write the fractional part again. So 0.45 as it is multiplied with 2 is 0.9, right? Here you can write 0 again. Now 0.9 into 2 is 1.8. 0.9 into 2 is 1.8. So the integral part is 1. So I am separating 1. Writing 0.8 separately. 0.28 into 2 is 1.6. So write 1 separately and you left with 0.6. Let me write with small letters here. 0.6 into 2, it is equal to 1.2. So write 1 separately and you left with 0.2. Okay, so it is not stopping anywhere, and uh, I am comfortable if I have the digits after the radix point up to 5. That's why I'm stopping here. So I need the accuracy of this conversion up to 5 digits after the decimal point. That's why I am stopping here. Now if you move from here, so if you move in this direction, right, and then from in this direction you will get the equivalent binary number. So 0.225, this is the given decimal number. For this the equivalent binary number is 0 point, what is the first digit? 0, second digit 0, uh, third digit 1, fourth digit 1, fifth digit 1, and it is getting repeated. So I want to stop here, and it is the equivalent binary. Okay, now when you convert this binary number into decimal number, you will get an approximate value, because our conversion is not stopping anywhere, and I have stopped at a particular value of my required accuracy. That's why you will get an approximate value. You will get an approximate value. But in this case, and in this case, in all the three problems, first three problems, you will get exact number. Okay, so this is about integral part and fractional part separately. Now when the number contains both integral part and fractional part, first you will convert the integral number, then you will convert the fractional number, add both the numbers. For example, if the decimal number is given like 36.375, now tell me what is the equivalent binary number. We know already for 36 we have found it as 100 100. So write it. Point for 375 0.375, we got it as 0.011. So I am writing here 0.011. So this is the equivalent binary number for the given decimal number. Okay, so if the number contains only integral part, you can follow successive division method. If the number contains only fractional part, you can follow successive multiplication. But if the number contains both integral part and fractional part, you can do them separately and add them. You will get the equivalent binary value. Okay, hope you have understood how to convert the decimal number into binary number. In the next video, I will come with some more examples with another conversions. Okay, so if you really like this video, please share and subscribe to my channel. Thank you very much.